Hello and welcome to an exciting new tutorial. This time I'll be covering iAssembly and user parameters because sometimes they do go hand in hand. Now, I do have an I-beam here constrained to another I-beam, and it is okay to constrain parts to parts. Sometimes, that's the best thing to do. It's really case by case basis. Sometimes, if I had a whole bunch of stiffeners and plates, I get a little nervous about constraining them to parts, and I start mapping out planes. And in this case, I am going to do that with this plate. I have two constraints, but I'm going to add one more constraint. Before I do that, I'm going to add a plane. I'm going to offset it from one of the origins planes, or from one of the assembly files planes, this XY plane. I'm going to offset it 120 millimeters for now. I'm going to constrain this spacer plate to that plane, and then I will turn off the visibility of that plane. Trying to think if I want to name it, maybe spacer position. Okay, so in an iAssembly, is basically I'll just read what it has to, what Autodesk has to say. It creates an iAssembly factory, so they call it a factory, comprising a table that lists unique members and their variations. So it's an assembly that changes, not radically, but even in the example that they have here, it looks like there's a different quantity of whatever those are, poles or whatever they are. You can change dimension values. You can change constraints. Like if you have something constrained, you can actually suppress that constraint. You can move things around. You can add holes, suppress holes. You can do all kinds of stuff. In fact, I'll demonstrate that here. We've also been using it to turn machining off and on so that we could show a pre-machined weldment in drawings. So let's start with a user parameter. So this this f of x icon is parameters. You can find it here under the Manage tab. This f of x parameters, you can find it here as well. And again, unfortunately, with Inventor or 3D modeling in general, there's almost always three ways. There's never just some definitive, straightforward way of doing things. I'm already thinking of two ways that I could do this. But the way that I've been doing lately is I've been actually opening up this parameters dialog box and creating a user parameter from scratch. So what is a user parameter? So basically at the bottom left here, if I click on this drop down arrow, I can see underneath there it says add numeric, add text, or add true false. So basically it's just a value that you can change or that you can use in your model. You can use it in a dimension, you can use it in a constraint. You can take this value and plug it in. You can plug it in all kinds of places. In fact, if I have these filtered right now. If I show all of the parameters, the D0, D1, D2, etc., these are all created by Inventor. So every time you add a constraint or you add a dimension, it adds a parameter just automatically. So you can even see that 120 millimeters that I plugged in here just a little bit ago, and it assigned D27 as the parameter. D27 has a value of 120 millimeters. So if I go back to my plane and I edit the dimension that's defining the position of that plane and I hover over the dimension, I see that it pops up D27 equals 120 millimeters. So there it is. I go back into parameters, D27. That D27 is being used. It's being consumed by this flush 5 constraint. Well, let me go back to this field. Let me go to rename. So if I was to rename it, this is basically all of them. So it knows that this the letter D followed by a number is the default parameter. But if I go to this filter and I check renamed, it knows that those have not been renamed, so it hides them. So any of them that have a unique name would now show up if I had, if I had created any parameters with a unique name, they would now show up. Well, I'm going to go ahead and create one right now. It almost acts like a table. I'm going to click on Add Numeric. So first of all, you have to name it. You can't use special characters and you can't use spaces. You can use underscore and hyphens and such, and it is case sensitive, so keep that in mind. And you want to use parameter names that make sense for the most part as often as you can. So for instance, let's just say I'll just say plate position, or it could, it's actually was what, spacer plate position. I could put spacer position, or even spacer plate position. Now as sometimes these descriptions get kind of big, so I do occasionally find myself using acronyms or making up abbreviations on my own. And if I ever do that, I'll come over all the way over to the right and I'll spell out what it means. So spacer plate position. So POS means spacer plate position. So I would recommend doing that because if anybody has to come back and troubleshoot these user parameters, or if you yourself have to troubleshoot it after a span of time, this will help you remember, okay, what is SP position? So those are just a couple of tips. I'll go ahead and type in, no spaces, spacer plate position. I'm going to type in the 120 millimeters that I originally defined in that plane. I'm going to copy this name, Control C to copy, and click Done. I'm going to go back to the plane, right click, edit dimension. I'm going to paste. I'm going to paste that spacer plate position in there, and I'm going to hit the green check mark. Now I'm going to move this assembly over to the right a little bit so you can watch it update in real time. I'm going to go back to the user parameters table, and I'm going to change the value, that 200 millimeter value, to 250 millimeters and hit enter. Now watch the assembly change. So you can see the plate moved because I've plugged this parameter into the model. So I'll change that back to 120 millimeters for now. Now, why is this useful? Well, when you create, let's say you had two different versions of this assembly. One of them, the spacer plate, is 120 millimeters from the end, and the other one, it's 250. Well, once you create your iAssembly table, you can change that value, that parameter value, in the iAssembly table. In fact, I'll go ahead and show you right now. So I'm going to, under the Manage tab, I'll go ahead and click on Create iAssembly, and it'll take a little time to get used to this window or tool. But at the top left, we have components, parameters, property, exclusion, iMates, BOM, and other. So all kinds of things you can add to your table. And the table that you're creating is down here at the bottom, or in this case in the center. I have mine expanded a little bit more than yours might be. But at the bottom, we're creating this table. Now at the left, you'll see the very first column is called member, and to the left of member is a disk, indicating that that is the file name that is going to be used to save the assembly. Every member that you add to this table is going to get saved as its own assembly file, and this is the file name it's going to use. The part number, on the other hand, right beside it, it can match the member number. In fact, most of the time it will, but it doesn't have to. The part number is not the file name. The part number is what will get plugged into iProperties. So, with that being said, and then since I created, anytime you create a user parameter and then turn your assembly into an iAssembly, it's going to automatically plug in your user parameters. Now you can right click and delete those if you don't want them. You may have some user parameters that you don't want to have in this table, and you can get rid of them. To add that back in, if it wasn't there at all, you want to go to the parameters tab Now, you have to know where a particular parameter has been used. Now, I would instinctively think, well, I used it for a work feature, I used it for a plane. In fact, I used it for the spacer position plane. But that's not where I want to go. Here's why. If I double click on anything in the iAssembly author window here, it adds it to my table down at the bottom. It also adds it to this window on the right. But you can see on the top it says D27, which has a value of the spacer plate position parameter that I created. I actually want the name of the column to be spacer plate position, and I want the cell to be the value of that parameter. So I'm going to delete that column. I'm actually going to go underneath relationships, and when I offset, or whenever you offset a plane, it's basically creating a relationship from between the plane from which you offset and the new plane. So you have to go through, and sometimes this can be difficult to find a parameter, but you have to go through and find where that parameter is used. So you're not going to just find a list of parameters. You have to actually go where it was used. So this flush 5 relationship has that spacer plate position user parameter, and you can also see the value. So if I double click on this, you can see it puts a spacer plate position column in there with the value of 120. So it can be a lot of work to add a new user parameter into your iAssembly table, but that is how you have to do it underneath the parameters tab. Okay, so I want to demonstrate how these user parameters can also be used, well, really with anything, but in particular machining, because one of the things we've been doing, of course, with iAssembly, like I said, is that we've been suppressing the machining with it, and that's right now the only justification I have for that is that that iAssembly that has the machining suppressed can be used in a presentation file to show an exploded view of a pre-machined weldment. So that's pretty much where I stand right now, or where we stand. So anyway, let me add some machining to this weldment. So I'm going to start a new sketch. I'm in the machining environment. Start a new sketch. I'm going to use this plane here, and I'm going to this plate. This is the weldment. It goes to the machine shop, and it's going to get machined. I'm going to hit F7 to slice the graphics so I can see all of my sketch here. Now I'm going to project this spacer plane. Again, you're going to think of 2 or 3 different ways that this can be done. This just happens to be the way that I'm doing it. Okay, so since this plane is used to position the plate, I'm also going to use it to kind of drive the position of the machining. The machining gets done on the plate anyway, so wherever this plate goes, the machining is going to go with it. Now I'm always a little cautious about constraining a sketch to geometry when I'm using an iAssembly. Another what I call inventor bug is that if you suppress a feature, such as an extrude feature that creates a notch, it will give you an error saying that that geometry needed for the sketch is no longer present. Well, yeah, it's because I suppressed the feature, so why don't you just suppress the sketch too that goes with it? So, for instance, if I make this line collinear with this, once I extrude this and I cut this rectangle out, once I suppress that feature, that extrude feature that cuts the rectangle out, the sketch will then have a problem. I've seen that it may not happen in this case, but I have seen it happen. In fact, I'll just go ahead and move forward and we'll see what happens. Now, let's say, maybe this rests on something, and from from here to here, I need a 112 millimeter depth, and that's where the the mounted item is going to rest. Yeah, I can just give this a width. Now, the problem that I was talking about, where sometimes the sketch will fall apart once I suppress this. Matter of fact, I'll even just try it. Like, let's say, for instance, I want to suppress this extrusion. So let's suppress it. Suppressing assembly features will also suppress dependent relationships. Yes. Okay, so it didn't blow up. Now, if it does, sometimes this little design doctor will come on and it'll give you problems. If that does happen, let's see here. I'm going to unsuppress that. You have to kind of get a little more creative with your sketch. Like, for instance, see F7. Well, let me press F8 and I'll get rid of this constraint. Having a hard time seeing my keyboard here. So maybe, I would then just maybe give this somewhat of a random depth. Like, I know that I'm never going to machine more than 3/8 of an inch, so I'll give it a random depth like this, and that gets rid of that collinear relationship that I had between that projected line. In fact, I can get rid of that projected line now, I believe. Yeah. Anyway, I probably shouldn't try to make theoretical problems. They kind of have to be resolved on a case-by-case basis. So, yeah, I apologize for overcomplicating this with those theoretical problems, but, I just trying to throw in some solution tips as I go along here. Okay, so I'm going to go ahead and go make sure I'm back in machining. I think this is where, okay, new sketch here. I'm going to add a hole here. I'm going to project that spacer position plane again and dimension this hole from there. Sometimes I use planes a lot. Sometimes maybe you want to use a line instead. Well, again, I'll just leave it at that. Okay, put a hole in here. I'll do a rectangular pattern. Actually, let me try suppress the hole. Okay. Alright, so I suppressed the hole, and then I suppressed the notch. And now I have an error. Could not find the face or invalid face for defining the sketch coordinate system. Use redefine sketch to select a new face. Accept. And I've got my design doctors lit up. And let's see what the problem is. Okay, so that face on which I put my whole sketch is missing. Yeah, who cares? The hole is suppressed. It's not even on. But yet, the sketch has an error. Okay. And this is, I guess this is kind of where the hypothetical has now become a real problem. So, I have no explanation for that. That's just a bug that needs to be issued, or addressed. Sorry. So, I guess I'll unsuppress these. Okay, so the solution is I would create a plane. Like, so for instance, let me see where these planes are here. And this is why sometimes assembly and machining and all this takes a lot of thought. Maybe a little bit too much for a tutorial. you have to kind of decide. Okay, well, I'm just going to say that I did a poor job of putting this assembly together. I'm going to unground this so that I can move it. I'm going to constrain the bottom of this beam to this plane. Okay. And I will constrain, I'll just continue constraining that beam. And one more. Okay. The reason I did that is because I want to offset a plane from the very bottom. So this bottom plane, the XZ plane, is some sort of a mounting surface or the floor or something. And from that mounting surface, 120 or it was 100 millimeters above that mounting surface. That was the wrong number. I couldn't remember the number I used in this sketch here. 112. Okay, so 112 millimeters. Dimension. Okay, 112 millimeters above, and you're going to like this anyway. So this is good. 112 millimeters above the floor plane or the bottom mounting plane. In fact, sometimes I'll even add a little extra name in these planes. Like it could be bottom mounting plane or mating plane. Okay, so from the mating plane, to here, I'll put this. I'll put cross brace mount position. Okay, so a couple things I'm going to do. First of all, I'm going to go back to the machining environment. I'm going to edit this sketch, the very first one, the notch itself. Edit that sketch. Press F7 to slice the graphics. I'm going to get rid of this dimension. I'm going to project that new plane. I'm going to make this line here collinear with the plane that I just projected. I may have missed something here. Collinear here, here. There we go. Okay, fully constrained. So I'm going to hit Finish Sketch. Now I'm going to go to the Hole feature, right click. I'm going to, I was looking for redefine, but, oh, maybe it's the sketch I have to, yeah, I have to redefine the sketch. Okay, right click, redefine the sketch. I'm going to put that sketch on this new plane. Okay. Now the sketch is sitting on that plane. It's not on that face anymore. So when I suppress that face, it's not going to cause any problems. And I'll even demonstrate that. So let me turn the visibility of that plane off. And now I can just even suppress the notch and leave the hole there. You might even be able to see the hole. Yeah, there it is. It's still there. It doesn't care. It doesn't even know that that extrusion is suppressed. Because instead of using the face in that extrusion feature to define my sketch, I used a plane. So I'll turn that back on. So that fixes that problem. Now here's what's really cool is that let's say something changed. And that does make my model a little more powerful. Is let's say, okay, that notch wasn't deep enough. It needs to be 110 millimeters. So I'll go to the plane. Right click, edit dimension, change it to 110, makes the notch deeper, and it also moves the hole down because that hole is on that plane. So no matter what I do with that, it's always going to move and not cause any problems. So, and that's actually what I just showed you right there with that plane. That's what I do. That's actually become my general practice, is creating planes and you know, adding machining features based on those planes. And yes, I could add that value into, I could create a user parameter for that value, and I could drive that value. In fact, man, might as well go ahead and add it. We'll just put cross brace notch depth. So let us have a little more fun with our table when we create it. So I'll just paste that in there, and there it is. So anytime I change that parameter, I'll have it. So I'll go back to machining. I wanted to put a rectangular pattern on that hole. X-axis. Again, I would put more thought and planning into the. Oh, I didn't mean to do that. I meant to do both directions with just this one feature. And 50. Okay. So now let me go ahead and save this. Now I've already turned this into an iAssembly, so in order to edit the table you have to go over to the left, and there's now a table here, and there's only one part so far, but I have to right click this and click on edit table. Now you can also edit via spreadsheet, and if you need to move columns around, that's how you would do it through Excel, but I prefer to use, well actually you kind of have to use this iAssembly author first to plug in. Well, I don't know if I should say you have to. It's just a little bit, it's just, I would start by using this, and then as you get better you could use Excel more if you choose. Okay, so, well, as you can see, my other parameter is not in there, so I'm going to add it. I'm going to go to parameters. Now you can see I have some plus signs beside a few more things in here. I have assembly features, which would be the machining. The extrusion, oh, I should have named these. It is helpful to name these when you're doing iAssembly, especially when you get a whole lot more machining. Again, just my own personal naming convention. It would be nice if we had like a standard, but you know, I guess that'll come in time. So we'll mill surface for the cross brace notch, and you could still call it hole, but just put maybe cross brace mounting hole. And I'll copy that, and I'll put, or I don't have to put hole twice, that's kind of redundant. Hole for cross brace mounting, and then okay, table, edit table. Now when I go to parameters and go through my assembly features, I can see them. You know, with a few features, it's not a big deal, but the more you add, of course, bigger deal it becomes. So now, okay, so where is my? Okay. Let's see here. So I have to find, it's probably one of these last relationships. There we go. Cross brace notch depth of 115 millimeters. I'll go ahead and plug that in there. Now, so I'm going to change these values between each iAssembly part. You know what? But I'm also going to exclude the machining. So I have components. Now, in components, it's pretty interesting. There's all kinds of stuff you can do. And over time you'll learn those. In here, if you had an I part, I don't want to go too much into I parts. I part is similar to iAssembly. I part is just a part, and there's different versions of that same part. You can actually change which I part member you use, and you would do that on the components tab. The parameters tab we've covered pretty well. Properties tab is I properties, which is really nice, especially if you're adding new versions. The description can change, so I'm going to go ahead and throw description in here, and that's going to fill out the I properties. So This is mounting assembly model F. See here. Okay, so those are all I properties, and you can change them in your table. Exclusion. So this is suppression. So you can turn things on and off, and you can do it with relationships and machining and components. And sometimes you have a right and a left version of parts. Well, what I'll do is I'll constrain both the left and the right version of the part, even if they're overlapping and interfering with each other. And then I'll come in here and I'll include or exclude the right and left version, depending on whether or not it gets used, for that particular iAssembly. There's all kinds of things you can do. So you could really have a big I should have hit OK instead of cancel. I think I just lost my work. So you could have a big mess of an assembly in here, all kinds of things, and then you go into your table and you turn things on and off accordingly. Okay, so exclusion, I want to go to assembly features, which is all the machining. I'm going to add all three of those in there. What else? There's all kinds of things you could do. Okay, so you can see it says include or exclude. Sometimes, and this one has a drop down. Other times, I think with parts, with components, if I want to exclude a component, like let's say I want to just not even have the spacer plate at all. In fact, we'll throw that in there. Oh, it does have include. What's going to happen is eventually you're going to have one that says suppress or compute. And that one does not have a drop-down box. So, and I'm not sure why, but you have to actually type in suppress or compute. I just can't remember what causes that one. Maybe it's a mate. No? If you ever add a column that you don't want, just delete it. Okay. So iMates I'm not good at. I have only messed with those a very little bit. Bomb, I've never done anything here. And then other would be like if you wanted to change the color, which I have done before. So if I click on here, new item, a little new item column shows up. If I right click on that, maybe that only works with iParts. Maybe I'm getting iAssemblies and iParts. Sorry about that. I think I'm getting iParts and iAssemblies mixed up. There should be a little material, no, it says appearance, I think. You right click and it says, gives you an opportunity to choose appearance. So sorry about that. Okay, so that covers all the tabs. So if I want to add another member, I have to right click on this row and click on insert row. And you can see the member number has automatically increased from 01 to 02. The part number is also changed from 01 to 02. It added that suffix on there. Now I'm gonna, let's see. Now let me go ahead and add a third one as well. So insert row, and I would go through and I would change all these columns, and we're gonna call them values, and we're gonna do that here in just a second. But let's start with the member number and part number. So let's say -01 here, I wanted that to be the weldment, pre-machined weldment. So what I can do is I can put, I could just leave these alone. You don't have to do what I'm doing now, but I found it to be kind of helpful. So let's say you are going to have a part and you want to show it pre-machined and also put in after machined. What you could do, what I've been doing, is you can add a W for weld and M for machine. Now what's going to happen is when I get out of this cell, Inventor is going to give me a warning. It's like, hey, you changed the file name, just so you know. So I'm going to click out of there, and it says a member name has been modified, which will alter the file name of the member. And I'm fine with that because I haven't even generated the files yet. And generating the files means saving the files themselves. It's going to save each of these assemblies as individual assemblies, and it's going to manage it itself too. So anyway, this next one I can change it to -01M. Then the part number, now remember the part number is just iProperties. So the part number can match. It doesn't have to be unique. So I have machining test 2-01 and machining test 2-01. So in a bill of material, it'll always show up as the same part number, but the the W and the M will give it two unique file names. Another thing I found helpful is I'll go to properties, which is iProperties. I'm not even sure why it doesn't say iProperties, because that's literally pretty much all you're seeing here are iProperties. Let's see here. Oh, what I do is I quote unquote hijack. I guess I could create a custom property. What I've been doing recently is I'll hijack an iProperty that we aren't currently using, such as project. So I'll double click on that, and it added the project iProperty to my table. So, and I'll throw a note in here. I'll say weld or welding or welded, and then in the other one I'll put machine. So I have the weld version and the machine version. So what I'll do is I'll go through my table, 120 millimeters, 115. The name stays the same. In the welded version, I'll press E to switch to exclude. So I'll exclude the machining. Exclude. It does get the spacer plate, so I'll keep that included, and that's it. So the difference between -01W and -01M is that this one includes all the machining and this one excludes it. Okay, so that's how you have two different versions. And currently, like I said, the only reason to do this, now that we've discovered view representations, is that I wasn't able to get a view representation to work in a presentation view. This whole practice of having a welded and a machine version might go away, but that won't make iAssemblies go away, because they are very, very useful. So I'll go ahead and demonstrate that from here. So that kind of covers the whole turning the machining on and off thing. Now I'm going to go through here and I'm going to start changing some of these values. So I'm going to change the spacer plate position to 250. Change the cross brace notch depth. This is for model G. It will get all the machining. Okay, that's good. Let me create another one here. Insert row. And you can see it incremented it from 3 to 4, which is really nice. Like, I usually leave that alone. I let it add those suffixes by default, and it works just fine. This one, we won't even have to, this one I'll just turn everything off. In fact, this is the one that doesn't even get a plate. So we'll exclude everything, exclude all the machine, and exclude the spacer plate altogether. So these spacer plate and cross brace notch values pretty much have no purpose, so you can just leave those alone. And just for fun, I'll add another one in here. Maybe I'll go, we'll see what 90 does. 90 and 117. All kinds of things you could do. Sometimes you could have some that could have other holes, holes for two different items, and maybe one of the set of holes you'll turn off and the other you'll leave on. So in this one I'll just go ahead and the hole I'll exclude. Oh, I meant to actually include the machining. No, I didn't. Getting confused with my own imaginary table here. Okay. Yeah, I'll go ahead and include the surface and exclude the hole and include the plate, of course. So there I've created a few different versions. So I'll go ahead and hit OK. And it's going to create all those different versions. In fact, it's changed already, and it's showing one of them. So when I expand this table, okay, so here's machining test 2-01W, W telling me it's welded. If I double click on -01M, there's my machining. So now I have two different iAssemblies that I can use in my drawing to show the two different states of this same, weldment. Now I'll go to -03, and that moved the plate, and it made the notch deeper. I'll go to -04, no plate at all. Every now and then it will want you to rebuild the assembly. I'm not sure why. And then number 5. So there it is. It's no holes, but with a real shallow notch, or a a notch farther away from the plane. So that covers that. Covers the user parameters, the real usefulness of it. I should really show you some of my user parameter tables. They're huge. You actually have to scroll your mouse wheel through them. And maybe before this is over, maybe I will show one. So that's it. Now, these files don't actually exist yet. So in order to make them exist, what you have to do is select them all by left-clicking on the top one, holding down Shift, and left-clicking on the bottom one. Or of course, you can hold Control and select them all. But you just want to select them all, and then right-click on one of them, any of them, and click on Generate Files. Do you want to save changes? Yes, I do. Now, what it's doing is it's creating a subfolder. So the folder that contains this assembly, it now has a subfolder in it, and in that subfolder are all the assemblies. In fact, I should be able to show you what that looks like. Let me think where I put this. Oh. Okay, so machining test 2 is my Weldment, and it created this folder, machining test 2, and here they all are. Here are all the different versions, and you can actually even see them in the little preview window. So now if you go through and you make changes to your table, you're going to want to go through and generate the files again to keep them updated. It doesn't generate the files automatically. Okay, so actually that's it. I'll go ahead and put this in a drawing. Create a drawing view here, and I will showcase one of my user parameters screens. You're gonna be shocked, I think. I don't know. Okay, anyway, so actually I'll stop right where I am. If I go to the Model State tab, this is where I can choose which member of the iAssembly family or the iAssembly factory that I want it to show. So I could actually change this right now, and you can see it updating in real time in the views, all the different versions. I think iParts and iAssemblies are great. They are just great to manage, and you can manage so many versions and so many features, and I really am a fan. Anyway, let me go and click OK here, and there it is. And yeah, I do believe you can just change the member even after you have the views placed. So it even updated the isometric view. So there you have it. And let's test the bill of material real quick. Let's go to the one that doesn't have the plate. Annotate parts list. Double click. Oh, I see why. Okay, currently the quantity for this is an ISM, or not iAssembly, Content Center I-beam, and so the unit of measure is quantity, or I'm sorry, inches, and you can see the length of each is 25, and the quantity over here is 50. So since there's two of them, it's taken the length of each and multiplied it times 2. Otherwise, if I had the quantity, I may be able to change the unit of measure, but I think you get the point there. So, Content Center stuff, you have to, it's a little bit of tweaking there, but it worked. I mean, the plate isn't there. So that's really great. It's powerful. So I'm going to go to this map file that I created just to show my user parameters. So again, it's just a dummy block that this is a map I used for the transfer truck, and I've got lots of planes here, positions for all the running rails, the cross girders, and I just pretty much map out where does everything live and what's driving its position. Where does it live and why does it live there? And I actually, I call this a map, but it could also be called a global parameters file. That is a term that you'll find every now and then on a web search. And basically you can have parts that are linked to this map. You can have assemblies, and you can link these user parameters. So let me go and click on user parameters here. And there is I'm not going to go into this much detail. I'll do this in another tutorial. You can link. So basically I've come through here and I've defined all the different parameters that are driving the transfer truck. And you can see some of the acronyms that I've created, like RRESOAL. What the heck is that? That is running rail end section overall length. And then I also put a description in for each of these as well, because I can even get lost in my own work if I'm not careful. So I just wanted to show this just because I just think that user parameters are great. They are a great way to manage everything. In fact, you can actually sort by the equation column, and sometimes I'll be looking at a drawing, you know, where we're getting our information, and I'll be like, I'll see like a 1050 millimeter dimension. I'm like, do I have that in here? And I find the 1050. I was like, oh yeah, there it is. Oh, okay, that's the supporting frame weldment width. And that supporting frame weldment width is driving something. That width of that weldment drives the position of something else. And not only that, but when I'm putting together the actual weldment itself, I can also use this parameter. So if I change the value of this user parameter, not only will my weldment get wider or narrower, but any other planes that I have in the map that use this value will also move. So items that are positioned according to this information will move, and then my weldment will also change in size. It's really powerful. I think it's a wonderful way to manage everything. So I just kind of wanted to showcase that, that's the level to which this can get. So okay, thank you.